Yeah, so like Brian mentioned, I'm here to talk about PAM for DevOps. And what is PAM? PAM is Privileged Access Management. And so the traditional PAM is geared toward people. Privileged Access Management means how do you protect the secrets of your most important assets, things like your passwords or your keys for your file servers, your web servers, your databases, your network appliances. You know, if any of those are lost to hackers, then they own your company, basically. So traditional PAM is kind of geared toward people. It's geared, you know, they have nice GUIs. It's all around how do we protect those secrets and how do we share them to the right people at the right time. So they set up workflows and processes for checking those out. They also have things like session management, session recording, so that you can go back and see what changes people have made in the past. Things like Heartbeat, where they go out and make sure the credentials are still working. And of course, they can do credential rotation, things like that. It turns out you need similar things for DevOps. I should say you need PAM for DevOps, but it's a whole different use case. And it's a whole different set of requirements. And so we're going to kind of dive into what those are specifically in this presentation. There you go. So I'm going to start off with the most basic use case. You know, we're going from monolithic pieces of code to trying to break it down into microservices. And so I tried to show that here with these different applications. And these applications now have to talk to each other. They have to talk to external services, and they have to talk to databases. And the traditional approach has been to hard code the credentials into that code. And so, of course, from a security perspective, if the programmer forgets and leaves them in there and they post it on GitHub, and the credentials are out there for everybody to see, or even if you're able to just get into one of these applications, then you can see the credentials for all the other ones and move laterally that way. So the very first step is replacing those hard-coded credentials with a centralized vault. Set up an API call to replace those hard-coded credentials. And, you know, a lot of people say, well, okay, now you're replacing a secret with credentials to get into this vault. How is that better? Well, it's better because now you have a centralized location where you can set up, you can control access, who has them. You can audit who did access those things. And you can set up rotation much easier. It's a lot easier to do that in one place as opposed to all these other different places. In this picture, if you're managing these applications in the traditional sense, then it's nice if you can have a SDK so that that automates, or it makes it easier to integrate those API calls. So in that case, you know, it'd be nice if whatever applications you're writing these in, whatever language, if there's an SDK that went along with that. If you aren't managing these in the traditional way, meaning you have Kubernetes or an equivalent, say, you know, Docker Swarm, it would also be nice if you had a way to connect Kubernetes to that centralized vault. So here I have a diagram of a traditional approach where not traditional in the managing sense, but in the way that a lot of people have set up plugins for Kubernetes. And what they do is they provide a sidecar that goes along with every application in every separate pod, and then they'll set up a separate pod that acts as the broker, and it'll be constantly watching for new pods to be developed or to be created and destroyed, and keeps track of that. And when they are created, it will go ahead and connect to it and reach out to your centralized vault, bring those credentials in. It can provide caching and things like that, and then inject those secrets right into the pod, and then your applications can use them. One newer approach that might be a little bit easier is to take advantage of all the built-in Kubernetes functionality. So in this integration, there's a DSV injector, or there's a centralized vault injector, and it can be watching for anytime Kubernetes does a create secret or update secret. And when it does that, it'll step in and do something called a mutating admission webhook, where it will go and make that call to your centralized vault and bring those secrets in seamlessly. Then it can go ahead and inject those into your etcd database into different secret volumes. So now your applications have access to those secrets, accordingly in the etcd. Going along with the theme of using the Kubernetes built-in capabilities, Kubernetes recently introduced encryption, so you can encrypt these secrets at rest. And they also have namespaces, so you can say application 1 here can be in the same namespace as the secret volume, and correspondingly application 2 can be in the same namespace as volume 2, and now this application does not have access to the other secret. So if there is a break-in and somebody's actually able to get access to one of these, they are not able to get access to the other ones. So the second big use case after implementing a centralized vault for all of your applications is the DevOps tools that go along with those. So all these tools I have listed here have their own secrets capabilities. I mean, I just showed Kubernetes had the ability to store secrets volumes within their etcd. But for the same reasons you want to have your applications have a centralized vault, you want to have all your DevOps tools have a centralized vault, again, for controlling access and auditing and being able to rotate those credentials. So it's nice also if you have plugins for these different tools, and here I just show a variety of tools that you would need in your DevOps arsenal as you go along your journey here. One of the things, and I mentioned that, okay, so the centralized vault is better, but there's still people in that first use case that say, okay, well, how about bootstrapping, and how do I, get those credentials to them in the first place? And so there's a lot of different methods, but when you use a cloud provider, they make it a lot easier. Because what you can do is if you're in AWS, then you can assign roles. If you're in Azure, you can assign service principals. And then if you're in GCP, you can assign service accounts. But whatever they call it, you can assign an identity to your nodes, to your EC2s or your compute engines. And with that identity, now they all have something called a metadata server, so that when you want to authenticate to the vault can turn around and hit those metadata servers and say, hey, is this application who they say they are? And they get their token, and then Vault says, okay, your centralized Vault can say, you are who you say you are. Now we'll give you the access that was prearranged in the Vault. So this is a fantastic way for bootstrapping and also to provide an independent authentication. The one downfall of this would be it's at the node level, right? So now all the pods have the exact same access. So that's cool if that's what you want, but it's maybe a lot of times you want one pod to have access to one set of credentials. You want to have another pod another set of credentials. One approach to this is the SPIFFE protocol. So they have another pod that you can add here, and it does the same function as these cloud providers. It provides this metadata that can provide a token to prove this identity. But one thing I noticed is Google in their Kubernetes deployment has made it so that you can apply a service account to the pods individually, and then those pods can directly contact your vault, be authenticated through the metadata server, and have their own individual rights. So I assume because Google has introduced that, if they start gaining traction, then the other people will follow and have their own ability to assign roles or service principals to those pods and provide that extra layer of isolation. You're going to want to allow your vault to be able to authenticate multiple different ways. Of course, you can have local client credentials. I mentioned the cloud authentication. But if you want to provide other identity providers or even access to other tools, it'd be nice if you have SSO capabilities, so things like OIDC and SAML. Another question people will have is like, okay, you mentioned rotation a couple times. How do we do that rotation? And actually, I was kind of being a little misleading because it might be better not to even have rotation at all. The entire reason you want to do rotation is because when whether it's your DevOps tool or your application, it's sitting on a server, it might even be in a pod, and there's a million ways that those credentials could leak, right? You're writing your own code, you might be buying code from somebody else, you've got open source code, there might be a configuration issue with the pod or a Kubernetes or a node or the network, and you just look at all these different places where there's potential leakage. That's the whole reason we need to rotate secrets. Well, we could also do something slightly different called a dynamic secret. So let's say your vault has the capability to like in this example I'm using Azure, say it has a service principal set up where this service principal has the ability to issue tokens or create other service principals temporarily. So in this example, I have Ansible, and let's say it wants to go off and do something. Instead of providing it with a static secret that can be lost, we have it reach into the vault and ask for a dynamic secret. And that dynamic secret can be set up to have a very fine-grained policy and time to live. And then the vault will go to Azure and either get a token or create a new separate service principal and provide those credentials back to your tool. And again, I have Ansible here, but it could be any DevOps tool, it could be any application. And then your tool or application can go off and do whatever it is. So let's say you want Ansible to fire up an EC2, or this is Azure, so a VM. And then you want Ansible to deploy code to it. Then you want Ansible to execute the code. You want it to do testing, whatever the case may be. You could sit here and create dynamic secrets for all of those different things, have different policies and different times to live. And when it's done, you ideally have it set up so that time to live will allow it to get done whatever needs to be done, and then it just expires. There's no rotation, there's no revoking, there's no going back and figuring out, okay, who had those credentials when they left. I have to make sure that they're gone. Dynamic secrets is a much easier way to do this than keeping track of rotating secrets, and more secure. So all the cloud providers provide ways of doing dynamic secrets. And the Vault has to have a little bit of extra capabilities, but you can also do this for databases. So the Vault itself will have to go in and say if it's MySQL, create a new role, have a time to live on it, and have the specific permissions tied to those credentials. And then when the time to live runs out, the Vault can go back in and delete that role. So there's capabilities for having dynamic credentials for a lot of different aspects. Another requirement that might come up for machines is certificates. And so in the traditional way a certificate is done is you'll have your certificate authority set up, and you'll have, just like in this picture, you'll build your root certificate and distribute that to all the different targets. And then, you'll take your private key and lock them up on your HSM and lock it away like it's in Fort Knox. And then you may or may not have an intermediate, but you'll have a poor admin, usually a human being, that has to figure out how they're going to get all the leaf certificates distributed to all the users and machines out there that need them. And this could be tens, it could be hundreds, it could be thousands of people or machines. And so your poor admin has to be able to identify them, make sure that they do have the rights to get to the targets that have the root credentials. And then they're going to probably issue a leaf certificate. It's going to be, a year long. They can't, there's no way a human being can issue leaf certificates, by the hour to all these different people. So the idea here is kind of to take out that registration authority part and automate it. So we go through the same process where the target, we create a certificate authority and we distribute our root certificates. And then we create an intermediate certificate and we install that in your Vault. Now, you use through, authenticate to the Vault through all the other methods you could, whether, like I mentioned, client credentials or the cloud provider, or however it is, authenticate to the Vault and request a certificate off of that intermediate certificate that is short-lived. Could be an hour, could be a day, but then you can go connect, and as soon as they're done, or when the time runs out, that leaf certificate expires. And so now they no longer have standing access. You no longer have to worry about this person leaving one day with their certificate and still having access. And you don't have to worry about rotating. As a matter of fact, rotation here would be cutting a new certificate, intermediate certificate, and replacing that in Vault if you wanted to do any rotation. So it'd be one process and automating the entire system to make it much easier. Kind of similar with SSH certificates, but they're done a little differently. They aren't chained as the same as they are with TLS or X.509. A lot of you are probably even more familiar with me on how it works with distributing SSH keys. First, you have your clients create their public-private key pair, and then they hand you the poor admin their public keys, and then they have to go to distribute them to all the targets out there. And now there's a different public-private key pair for every. It kind of goes up exponentially. All the different clients who want to connect all the different targets ideally, you'd have a different key pair for every combination. And so it becomes a disaster to manage. How do you rotate those? How do you control them? Again, it's standing access. What if this person leaves with the keys? What if this machine is infiltrated? So in this case, what you would do is you have your vault create a public-private key pair for your targets. And it could even be a set of targets. Say they're, you got an HA or scaling arrangement where they're the same machines, just duplicated. And then you have the vault, when they authenticate, create a separate public-private key pair. And instead of distributing these keys all over the place, what you do is you generate a SSH certificate where this key pair signs this key pair. So there's no longer any of the distribution of all the different public-private pairs everywhere. This has their own set, these guys have their own set, and they sign them. And again, this SSH certificate is short-lived so that the clients have access for just a short period of time. The certificate expires, and now there's no worrying about how do you rotate the keys in the future. And then, I've been talking about how there's human PAM and there's PAM for machines, but every once in a while, even though it's not an ideal situation, you're going to have the same credentials are going to need to be used in both places. They might be admin credentials, they might be database admin credentials or server credentials, but whatever the case may be, you need to give the application this really high level of access. And you want both tools to be able to do their things. You want the PAM to be able to control the human access, and you want the Vault to be able to do the authentication and the high-speed interactions with the application. So then it's nice if your PAM can be the source of truth, where you create the secret in the first place, it pushes it to the Vault, and like every time the PAM rotates that secret, it pushes that to your DevOps Vault. So now you have the kind of the best of both worlds.